There are rules to this universe, unwritten laws etched into the fabric of space-time itself. They are the silent conductors of the grand cosmic orchestra, dictating the graceful waltz of planets, the fiery lives of stars, and the inexorable march of galaxies through the void. We have spent centuries decoding this celestial rulebook, learning its language of gravity and light. We learned that for every action there is an equal and opposite reaction. We learned that energy can be neither created nor destroyed, and we learned one of the most fundamental truths of the cosmos, that in the cold, hard vacuum of space, objects are defined by the light they borrow. You see, the universe is overwhelmingly, profoundly dark. The brilliance we witness in the night sky is an illusion of proximity, a beautiful deception. The vast majority of matter, from the smallest grain of dust to the most colossal rogue planet, is inert and cold. It is a passive canvas waiting for the brush of a distant star. The moon that hangs in our sky, a beacon of hope and mystery, generates no light of its own. It is a cosmic mirror catching the sun's fire and casting a pale, second-hand glow upon our world. Mars, the ruddy spark that has captivated our imaginations for millennia, is not a world on fire. It is a world of rust, its surface simply reflecting the daylight of our star back at us across millions of miles of emptiness. Every asteroid, every comet, every distant moon of Jupiter or Saturn that our probes have unveiled adheres to this simple, inviolable principle. They are all defined by reflection. They are prisoners of the inverse square law, their visibility fading predictably into the black as they recede from their parent star. Their brightness is a mortgage, a loan from the local furnace of fusion, and a loan that is always paid back with diminishing returns over distance. This single principle is the bedrock of astronomy. It is how we measure distance, how we determine size, how we deduce the composition of worlds we can never touch. We analyze the sliver of sunlight that bounces off a surface, and in its spectral signature we can read its secrets. We can tell if a world has water ice, if its atmosphere holds methane, if its soil is rich in iron. It is a cosmic conversation conducted across impossible distances, all predicated on the simple, reliable physics of reflected light. We built our understanding of the cosmos upon this foundation. It was solid. It was certain. We believed we knew the rules of the game. Then something came visiting. Something from the outside. We were not entirely naive to the possibility of interstellar travelers. The space between the stars is not a sealed container. Our solar system moves through the Milky Way like a ship on a vast, dark ocean, and occasionally we encounter cosmic driftwood from distant, unknown shores. In 2017, we were graced with our first confirmed visitor, a bizarre cigar-shaped object we named Oumuamua. It tumbled end over end, a dark, rocky shard that defied easy categorization. It was an asteroid, perhaps, but of a shape we had never conceived. It accelerated away from our sun in a way that hinted at outgassing, yet we could detect no cometary tail. It was an enigma, a puzzle that sparked 1,000 debates and one tantalizing controversial theory that we had just been flown by an artifact of an extraterrestrial intelligence. But for all its strangeness, Oumuamua obeyed the fundamental law. It was a dark object reflecting what little sunlight it could. It was a whisper, not a shout. 2 years later, a second interstellar guest arrived, a comet named 2I, Borisov. This one was more familiar. It was a rogue comet hurled from its home system by some long-forgotten gravitational melee. It sported a magnificent tail of dust and gas, a classic cometary display that shone brightly in our telescopes. And yet, like Oumuamua, and like every other object we had ever seen that wasn't a star, Borisov's brilliance was borrowed. It was a spectacular celestial mirror, its icy surface sublimating under our sun's warmth and releasing a cloud of reflective particles, but it was a mirror nonetheless. These visitors were strange, they were thrilling, they stretched our definitions, but they did not break our physics. They were playing by the rules, even if they were from another part of the cosmic stadium. They reinforced our confidence that the laws we observed here were universal. The universe, it seemed, had a consistent grammar. Then, on a quiet night in Hawaii, the unblinking robotic eyes of the Asteroid Terrestrial Impact Last Alert System, or ATLAS, recorded another faint smudge of light moving against the stellar background. On the surface, it was a routine discovery, one of hundreds made every year. The initial designation was provisional clinical, a string of numbers and letters. To the automated systems, it was just another data point, another potential near-Earth object to be catalogued and tracked. Its trajectory was calculated, its orbit plotted, and that's when the first quiet alarm bells began to sound in astronomy offices around the world. The arc of its path was not a closed ellipse tethering it to our Sunday. It was a wide, sweeping hyperbola, a clean, unmistakable path of entry and eventually exit. This was not one of ours. This was the third visitor. This was 3I, Atlas. Immediately, telescopes swiveled to get a better look. Astronomers and researchers scrambled for observational time, eager to study this third precious sample from the interstellar medium. The initial data began to trickle in, and the object behaved as expected. It was faint, a barely detectable pinpoint. As it fell inward toward the heart of our solar system, its brightness began to increase just as physics demanded. The closer it got to the sun, our system's great lamp, the more light there was for it to reflect, and the more brilliantly it shone. Everything was proceeding according to the cosmic rulebook. It was perhaps a touch brighter than expected for its estimated size, suggesting a highly reflective icy surface. A third interstellar comet, perhaps much like Borisov. The mystery felt manageable. We had a frame of reference. We began to build our models to make our predictions. But this object was not like the others. It was not a piece of driftwood. It was not a celestial mirror. As the global astronomical community watched 3I, Atlas began to do something that was for all intents and purposes impossible. It began to defy the very laws of light that had guided our understanding for centuries. The first hints were subtle, buried in the noise of the data. A slight deviation in its light curve, the graph of its brightness over time. Perhaps it was a measurement error. Perhaps it was an unusual pocket of gas erupting from its surface. Explanations were offered, models were tweaked, but the anomaly didn't go away. It grew. The deviation became a flagrant violation. As the object continued its journey, its brightness did not simply follow the predictable curve of reflected sunlight. It began to surge in ways that had no correlation with its distance from the sun or its angle to the Earth. It was as if a celestial dimmer switch was being turned, but no one could find the hand that was turning it. Imagine you are standing in a vast dark field and a friend is walking away from you with a simple mirror. The further they go, the smaller and dimmer the reflection of your flashlight on their mirror becomes. This is the inverse square law. It's simple, intuitive, and it governs every single inert object in the cosmos. Now imagine your friend is walking away and the light from the mirror is not getting dimmer. Imagine it stays constant. Or worse, imagine that as they walk further into the darkness, the light from the mirror inexplicably gets times brighter asterisk. You would be forced into one of two conclusions. Either the laws of physics as you understand them are wrong, or what your friend is holding is not a mirror at all. It is a lantern. This was the chilling, paradigm-shattering realization that dawned upon the teams studying 3I, Atlas. The data was irrefutable, cross-checked by observatories across the planet. The photons striking our detectors were not all coming from the Sunday. The object was not merely reflecting light, it was contributing. It was adding its own luminance to the equation. In the utter frozen blackness of interplanetary space, hundreds of millions of miles from any source of power, this tiny solitary object was actively, demonstrably, and impossibly on. It wasn't just shining, it was projecting. The implications of this discovery are so profound, they verge on the terrifying. We are forced to confront a cascade of questions, each more unsettling than the last. What natural process unknown to our science could allow a cold cometary body to generate its own light? There is no known chemical reaction that could sustain such a glow in a vacuum. There is no known radiological process that could produce this specific, stable signature of visible light. It is not a star. It is far too small, far too cold. It is not a brown dwarf. Its trajectory proves it is a solid object navigating space like a rock, not a ball of plasma. It breaks every category we have. It tears up the cosmic rulebook and sets the pages on fire with its own inexplicable glow. We are left floating in a sea of radical, fantastic possibilities. Could this be a new type of celestial object entirely? A kind of cosmic crystal forged in the heart of an alien nebula that can absorb stellar energy for millennia and re-emit it slowly like a celestial phosphorescent stone? Could we be witnessing a form of geological activity so exotic it borders on science fiction? Some kind of cold, solid-state fusion occurring within its core? Or does the answer lie not in geology but in biology here on Earth? In the crushing blackness of our deepest oceans, life has learned to create its own light. Bioluminescence is nature's answer to eternal darkness. Could we be looking at that same principle scaled up to an interplanetary interstellar level? Are we witnessing the glow of a colossal living organism traversing the void? A creature born in the darkness between stars for which light is not a reflection but a metabolic process. And then there is the final, most whispered about possibility. The one that keeps scientists awake in the dead of night, staring at the paradoxical data on their screens. The light we are seeing is not chaotic. It is stable, controlled. It does not flicker and flare like a random chemical eruption. It holds a steady, consistent output. At what point does a process so ordered, so contrary to the universe's natural tendency toward decay and entropy, cease to be a natural phenomenon? At what point must we consider that a lantern in the darkness implies a lantern maker? We have been scanning the heavens for decades, listening for faint radio signals for communications from other intelligences. We've been searching for a message in a bottle. All that time we assumed that any advanced life would talk to us, that they would use a medium we were expecting. Perhaps we were profoundly wrong. Perhaps the first sign of intelligence beyond our own wouldn't be a message at all. Perhaps it would be a lighthouse silently gliding through our front yard, built by minds whose intentions and origins remain utterly terrifyingly unknown. The arrival of 3I, Atlas, has shattered our comfortable assumptions about the universe. It has presented us with an object that should not exist behaving in a way that should not be possible. It is an interstellar phantom that refuses to be a ghost, a visitor that has brought its own light to the party. We now stand at a precipice of discovery, forced to re-evaluate the most fundamental laws of nature. We thought we were merely cartographers of the cosmos, mapping the predictable reflections of a known reality, but we were wrong. There is something new out there in the darkness. Something we did not predict. A mystery is unfolding in real time, a silent, luminous enigma that beckons us forward. Our task is now to chase this ghost, to understand its impossible fire, and to confront the profound truth it may reveal about the universe and our place within it. The journey to understand what 3I Atlas truly is has only just begun, and it will take us to the very edge of what we know. What if a message from the stars wasn't written in language, but was instead composed in the silent universal syntax of light? What if it wasn't a signal aimed deliberately at our receivers, but a passive luminous statement, an artifact of impossible engineering, drifting through the dark, waiting for eyes capable of seeing it for what it truly is? For decades we have scanned the heavens, listening for a whisper, a coded sequence, a structured radio burst to announce we are not alone. We built our listening posts, our great electronic ears, and trained them on the void, straining for a voice in the cosmic static. All the while we were also watching, not for messages but for threats. Across the globe, a network of sentinels stands guard. They are the Asteroid Terrestrial Impact Last Alert System, or ATLAS. 4 telescopes, 2 in Hawaii, 1 in Chile, 1 in South Africa, forming a sleepless, all-seeing eye for our small, fragile world. Their task is relentless, unglamorous, and profoundly important: to scan the entire observable sky every 24 hours. They are not searching for alien fleets or listening for galactic greetings. They are looking for the silent assassins of the solar system, the city killers, the rogue asteroids and comets on a collision course with Earth. It is a job performed not by astronomers in lonely domed observatories, peering through eyepieces with romantic wonder. It is a task for cold, hard computation. Each night these robotic telescopes drink in the starlight, capturing immense digital panoramas of the heavens. These images, petabytes of raw data, are fed into powerful computer systems, which meticulously compare them to the images taken just hours before. The software is a master of celestial pattern recognition. It knows the precise position of every catalogued star, every known galaxy. Anything that moves against this fixed stellar backdrop is flagged, a ghost in the machine, a point of light where none was before. Usually these ephemeral apparitions are familiar players in the cosmic dance. A known asteroid completing its silent clockwork lap around the sun, a piece of space debris, the forgotten shell of a long-dead satellite tumbling in the darkness of low Earth orbit. The system notes them, checks them against our vast catalogues, and moves on. The digital river of information flows without pause, a constant, vigilant stream safeguarding our planet from stony oblivion. On an otherwise unremarkable night, the system found something different. A single, unassuming pixel, a faint mote of light was moving. It was not in the catalogue. It was not a satellite. It was not a glitch. An alert was triggered, a quiet electronic chime in a server room, notifying the human astronomers on duty that a new object had entered the stage. This is the beginning of every discovery story, a moment of quiet potential. 99% of the time, these new discoveries are routine. Another near-Earth object to be catalogued, its orbit calculated, and logged, another entry in the immense cosmic ledger we keep to ensure our own survival. The initial observations were fed into the world's astronomical networks, and as more telescopes turned their gaze towards this faint newcomer, a preliminary trajectory began to take shape. And this is when the quiet potential erupted into scientific astonishment. The numbers being returned from the orbital simulators were not just unusual, they were, for an object found in our neighbourhood, impossible. To understand why, you have to think of our solar system as a gravitational valley with the immense mass of the Sun sitting at its deepest point. Everything that belongs here, the planets, the asteroids, the comets, is trapped within the sloping walls of this valley. They are on closed paths, elegant ellipses, celestial racetracks, from which they can never escape unless given a tremendous violent shove. Their orbits are a form of cosmic loyalty, a gravitational chain binding them to our star. We can trace these elliptical paths backwards and forwards in time, and they always remain within the Sun's domain. They are ours. But the path of this new object did not trace an ellipse, it traced a hyperbola. This is not the shape of a captured object. It is the signature of a slingshot. It's the path of a traveller, just passing through a cosmic tourist, arriving from one direction and destined to depart in another forever. It was moving too fast, possessing too much energy of its own, to ever be captured by the Sun's immense gravitational pull. It was not climbing out of our valley. It had fallen into it from somewhere else, from the incomprehensible space between the stars. This was an interstellar object. The designation it received was 3I, Atlas. The Atlas for the survey that found it. The 3I was the critical part. The I stands for interstellar. The 3 meant it was only the third such object humanity had ever definitively identified. The first one, Oumuamua, had shocked the world years earlier, a bizarre, tumbling, cigar-shaped enigma that defied easy categorization. The second 2I, Borisov, was more familiar, behaving much like a typical comet, a dirty snowball from another star system, reassuringly normal in its abnormality. Now we had a third visitor. The excitement in the astronomical community was palpable. Here was another priceless messenger from the interstellar deep, a pristine sample of the building blocks from another solar system delivered directly to our doorstep. Every major observatory scrambled to get time on this new target, to train their most powerful instruments on this fleeting guest before it accelerated back out into the eternal night. They prepared their spectrographs to analyze its chemical composition, their infrared cameras to measure its temperature, their photometers to chart its behavior, and as the first detailed photometric data began to stream in, the initial excitement began to curdle into profound confusion. The trajectory had told us where it was from, but the light it was giving off was telling a story that made no sense at all. The core of the problem was its brightness. It was ridiculously bright. Interstellar objects are expected to be dark. They have been traveling through the interstellar medium for millions, perhaps billions of years. This journey is not through a perfect vacuum. It's a subtle but relentless sandblasting by cosmic rays, radiation, and microscopic dust particles. This process, called space weathering, darkens and reddens surfaces, baking them into a dark carbonaceous crust. Oumuamua was a perfect example. It was incredibly dark, reflecting very little sunlight, as dark as asphalt, which is precisely what one would expect. 2I. Borisov was brighter, but that was because it was an active comet shrouding itself in a brilliant cloud of gas and dust, a coma which efficiently reflected sunlight, masking the darkness of the nucleus within. 3I. Atlas, however, was in a class of its own. It was far brighter than Oumuamua, yet initial spectroscopic analysis showed no signs of a significant coma. There was no vast cloud of outgassing material to explain its stunning luminosity. It appeared to be a bare, solid object, yet it was shining with an intensity that defied our understanding of how interstellar bodies should behave. This was the first flag, the first indication that our third visitor was going to be even stranger than the first. The real mystery, however, was not just its overall brightness, but how that brightness changed over time. To understand a distant object you cannot resolve into a picture, astronomers rely on a powerful tool, the light curve. Imagine charting an object's brightness second by second, hour by hour. That chart is its light curve, and it is as unique as a fingerprint. For a typical irregularly shaped asteroid, the light curve is a jagged, repeating wave. As the potato-shaped rock tumbles end over end through space, it presents its wider, more reflective sides to us, causing the brightness to peak, and then its narrower, dimmer ends, causing the brightness to dip. The pattern is predictable, cyclical but chaotic, the signature of a simple tumbling piece of rock. For a comet, the light curve is often dominated by a slow, steady increase in brightness as it approaches the sun, and its outgassing becomes more violent, followed by a slow decrease as it retreats. There might be unpredictable outbursts, flares of light as pockets of volatile ice are suddenly exposed to the sun's heat, but the overall trend is a gentle curve. So what was the light curve of 3I? Atlas? It was neither. It wasn't the chaotic, jagged wave of a tumbling asteroid. The data showed a stability, a regularity that was utterly bizarre. The object was rotating, that much was clear, but its brightness variation was unnervingly smooth and consistent. There were no wild, unpredictable jags. Instead, there was a controlled, almost metronomic pulse. A slow, deliberate rise, a sustained peak, and a slow, deliberate fall. It was too stable for a tumbling rock, yet it was also far too luminous to be just a solid object reflecting sunlight. The numbers simply didn't add up. For it to be a bare nucleus, shining this brightly by reflected sunlight alone, it would have to be made of a substance with an albedo, a reflectivity approaching that of freshly fallen snow. The existence of a celestial body made of such pristine material, after eons of weathering in the harsh interstellar environment, was considered fantastically improbable. It would be like finding a perfectly polished chrome sphere in a desert untouched by sand or wind. The alternative was that it was in fact a comet, but one behaving in a way we had never witnessed before. Perhaps it was outgassing in a perfectly uniform, continuous stream from its entire surface, creating a small, dense, but visually undetectable coma that was responsible for the brilliant light. This microcoma theory was an attempt to fit the anomaly into a known box. But it too began to falter under scrutiny. The light from 3I Atlas lacked the characteristic spectral signatures of the molecules, like cyanide and diatomic carbon, that dominate the comas of comets in our solar system. The light's color was also wrong. It wasn't the scattered, slightly bluish light we see from cometary dust. It was a pure white light, as if from a clean, direct source. This was the heart of the paradox. It was too bright to be an asteroid, but it didn't look or act like a comet. It was a confounding hybrid, an object that broke the most fundamental axiomatic rules of our celestial classification system. It was as if we had discovered a new animal in the wilderness that possessed the properties of both a mammal and an insect, a biological impossibility that forced us to question the very foundations of our understanding. This is where the ghost of Oumuamua returned to haunt the conversation. That first interstellar visitor had prepared us for strangeness. Its mystery centered on its motion. Oumuamua displayed a slight but persistent non-gravitational acceleration, a tiny push that couldn't be explained by the sun's gravity alone. The leading natural hypothesis was that it was outgassing in a way we couldn't see, propelling it gently like a tiny leaky rocket engine. Other, more speculative theories pointed to its extreme shape and suggested it could even be a solar sail, a piece of alien technology. But Oumuamua's defining characteristic was that it was faint, dark, and inert, its secrets hidden in its subtle movements. 3I, Atlas, presented us with the complete opposite. Its trajectory was so far perfectly predictable, obeying gravity to the letter. Its mystery was not in its motion, but in its light. It was not hiding its secrets, it was shouting them. It was a brilliant celestial beacon, and the message it was broadcasting was one of profound physical contradiction. Where Oumuamua was a whisper, 3I, Atlas was a declaration. The scientific community began a frantic process of elimination. Could it be a fragment of an iron-rich planetary core from a shattered world, its metallic surface polished to a mirror shine? Perhaps, but such an object would still tumble, producing a light curve with the sharp glints and deep fades of. He reflected light off flat and curved surfaces, not the smooth, controlled pulse we were observing. Could it be a nitrogen iceberg, a shard chipped from a Pluto-like object in another star system, its surface sublimating into an invisible gas that somehow focused sunlight in this peculiar way? This was a more promising avenue, and an attempt to explain both the brightness and the lack of a visible dust coma. Yet even this model struggled to explain the almost engineered stability of the light curve. The outgassing of a nitrogen iceberg should be chaotic, driven by the uneven heating of a rotating irregular body, creating unpredictable flares and jets, not a steady rhythmic glow. Every conventional astrophysical model we threw at it failed. Every natural explanation required us to invent new, unobserved phenomena to bend the rules of physics in just the right way to make the data fit. The object was behaving with a composure, a consistency that felt less like the chaotic fury of nature and more like the output of a regulated system, a system that was not merely reflecting the light of our sun back at us. The data was painting an impossible picture, one that led to a radical, unsettling conclusion, a hypothesis that hovered at the very edge of science. The light curve was so stable, so clean, so unlike any natural reflection, that it forced us to ask an unthinkable question. What if the light was not a reflection at all? What if the object itself was the source? We found ourselves staring across the dark at an interstellar traveler that was not just a passive piece of rock or ice. It was an active participant broadcasting a steady, brilliant signal that defied every known convention of celestial mechanics and composition. Its light was a riddle wrapped in a mystery inside an enigma, and its arrival marked a turning point. We were no longer just looking at a messenger from another star. We were confronting a phenomenon that our science was perhaps not yet equipped to understand. The trajectory told us it was an outsider, but its light suggested something more. Something that would demand we reevaluate not only what objects can drift between the stars, but the very nature of what we might find when we finally look deep enough into the dark. The journey to understand this impossible light was just beginning, and its revelations would challenge us in ways we could never have foreseen. That first faint notification from the Minor Planet Center had acted not as a whisper, but as a thunderclap across the global astronomical community. It was a digital call to arms, a summons for every mirror, every lens, every array that could be wrenched from its scheduled duties and aimed at this fleeting visitor. From the bone-dry clarity of the Atacama Desert, where the very large telescope's 4 colossal eyes blink open to the cosmos, to the sacred volcanic peak of Mauna Kea, where the twin Keck giants taste the starlight, a silent, frantic pivot was underway. You see, in astronomy, time is the most precious and fiercely guarded commodity. To abandon a carefully planned, peer-reviewed observation is an almost unthinkable act, a sacrilege against the meticulous march of science. Yet for 3I Atlas schedules were shattered, long-term projects studying distant galaxies were paused mid-exposure. The hunt for exoplanets around nearby stars was momentarily abandoned. This was not merely a new object of interest. It was a crisis of understanding, unfolding in real time, a single point of light that threatened to unravel the neat tapestry of celestial mechanics we had so carefully woven. The initial shockwave of its discovery, that impossible brightness, where only darkness should be had, now subsided, replaced by a feverish, desperate hunger for data. Every photon collected was a potential clue. Every pixel on a CCD sensor was a ballot cast for or against insanity. The first and most powerful tool unsheathed in this campaign was the spectrograph, the grand inquisitor of astrophysics. For centuries, we have used this instrument to break starlight apart to spread it into its constituent colors, just as a prism shatters sunlight into a rainbow. But this is no simple rainbow. Hidden within that beautiful band of color are infinitesimally thin, dark lines, or sometimes brilliant, bright ones. These are spectral lines, the unique, unforgeable fingerprint of the chemical elements present. They are a barcode of creation telling you if a star is burning hydrogen, if a distant atmosphere is laced with methane, or if a nebula is aglow with ionized oxygen. It is the language of the universe, and we have become fluent in its translation. The expectation for 3I, Atlas, was straightforward, almost mundane. Since it was reflecting the sun's light, its spectrum should be a near-perfect copy of the sun's own spectrum, just much, much fainter. We know the sun's barcode by heart, a dense forest of absorption lines, each one a testament to the elements churning in its fiery atmosphere. We expected to see that familiar pattern, perhaps slightly smeared or altered by the surface it was reflecting off of. If 3I Atlas were a typical comet, we would see the sun's reflected light, but superimposed upon it would be bright emission lines from the gases in its coma. The solar radiation would be energizing molecules like cyanogen, carbon, and hydroxyl radicals, causing them to glow at their own specific, well-documented frequencies. We were looking for the telltale signs of water ice, the ghostly glimmer of sublimating carbon dioxide, the very soul of a comet. The first spectral readings that came back were wrong. They were so profoundly, fundamentally wrong that the initial assumption at multiple observatories was instrument error. Frantic calibrations were run, systems were rebooted, data was reprocessed through different software pipelines, each team hoping to find the bug in the code that would explain the bizarre message they were receiving. But there was no error. The data was confirmed cross-referenced between telescopes thousands of miles apart, and the impossible truth began to settle in. There was no solar spectrum. The familiar dense barcode of our home star was completely absent. It was as if 3I Atlas had somehow scrubbed the sunlight clean of its identity before sending it back to us. Even more unnerving was the complete and utter lack of any cometary emission lines. There was no cyanogen, no carbon, no hydroxyl, no water. The chemical ghosts that dance in the halo of every known comet were nowhere to be found. The object was a void where a vibrant chemistry should have been. What we saw instead was something that chilled veteran astronomers to the bone. It was a smooth, nearly featureless continuum of light, a gentle swelling curve across the visible spectrum. This wasn't a reflection. A reflection carries the spectral identity of its source. This was something else entirely. This was a times source asterisk. The light was not bouncing off 3I Atlas. It was originating times from times it. It was a self-luminous object broadcasting a strange ethereal glow with no discernible chemical accent. The implications were staggering. In the cold, dead vacuum of interplanetary space, something was generating its own light, a process that should require immense energy, and it was doing so without betraying any chemical secrets. It was a perfect anonymous white light, a blank page where a detailed story was meant to be written. The silence of its spectrum was deafening. While the spectrographs were returning their hauntingly empty results, another more subtle investigation was underway. This was the domain of polarimetry, a technique that analyzes not the color or intensity of light, but its orientation. Think of a light wave as a rippling sine wave traveling through space. It can oscillate up and down, left and right, or at any angle in between. Light from a source like the sun is a chaotic jumble of all these orientations. At once it is unpolarized, but when that light bounces off a surface, a portion of it becomes organized, forced to oscillate in a preferred direction. This is polarization. It's the very principle behind your polarized sunglasses, which are designed to block the horizontally polarized glare reflecting off a road or a body of water. For an object like an asteroid or a comet nucleus, the sunlight reflecting off its dusty, uneven surface should become partially polarized in a predictable way. The exact degree and angle of that polarization can tell us a great deal about the texture of the surface, whether it's made of fine dust, large pebbles, or porous ice. It is a way of touching the object with light, of feeling its texture from hundreds of millions of miles away. The polarimeters were turned toward 3I Atlas, with teams expecting to get their first tactile sense of this enigma. Was it a powdery snowball? A jagged piece of rock? The answer would be in the subtle twist of the light it sent us. Once again, the universe refused to conform to our expectations. The data that streamed back from the world's most sensitive polarimeters was, to put it mildly, nonsensical. The light from 3I Atlas showed virtually zero net polarization. It was a perfect, unadulterated chaos of orientations, as if it had never interacted with a surface at all. It was as pristine and unscattered as the raw light from a star, yet it was not a star. It was like dipping your hand into a lake and having it come out completely dry. The observation made no physical sense. How could light supposedly originating from the sun and reflecting off a solid body show no signs of that interaction? It was another deep crack in the foundation of our understanding. Combined with the spectral data, a terrifying picture was beginning to emerge. The spectrographs told us the light wasn't a reflection of the Sunday. The polarimeters told us the light hadn't bounced off a surface. The two results were in violent agreement. The light was not reflected. It was projected. It was an emission, an active process from within the object itself, and it was a type of light that seemed to follow no known rules of physics. It was coherent in its own strange way, yet it lacked the chemical signatures of any known luminous process. The scientific community, now thoroughly rattled, began to grasp at straws. We are, at heart, a conservative bunch. We don't reach for radical new physics until every single conventional explanation has been exhausted, tested to its breaking point, and found wanting. The process began in earnest, a frantic scramble to fit the square peg of 3I Atlas into the round hole of established science. The most obvious explanation, the one everyone desperately wanted to be true, was that this was simply a comet, a very times weird comet. Perhaps the thinking went it wasn't made of the usual water and carbon dioxide ices. What if it were composed of something far more exotic, something that sublimates differently, creating a coma that is transparent to spectrographs? Models were run for a body made of pure solid nitrogen, like the surface of Pluto, or Triton. When warmed by the sun, nitrogen ice can flash directly to gas, potentially creating a vast reflective cloud. The models were spun up on supercomputers, simulating the physics down to the molecular level. They failed. A nitrogen coma would still interact with solar wind and high-energy particles in a way that produces a faint but detectable atmospheric glow, a signature that simply wasn't there. More importantly, the sheer brightness of 3I Atlas was impossible to replicate. To create a glow that intense through sublimation would require a nucleus far larger than its gravitational influence on nearby objects suggested, and it would be venting gas at a rate so prodigious we would have seen its trajectory altered. Its path through the solar system was unnervingly stable, a silent gliding motion completely untroubled by the violent outgassing needed to explain its appearance. The next hypothesis was even more esoteric. Perhaps the light was not from a gas coma at all, but from a cloud of fine crystalline dust. Certain materials, when flash frozen in a vacuum and then gently warmed, can form highly reflective, geometrically perfect crystals. Could 3I Atlas be shedding a continuous veil of this diamond dust, creating a perfectly reflective sphere around it? This theory had the advantage of potentially explaining the lack of a cometary spectrum. A pure dust cloud would simply reflect the sun's light. But this idea immediately collided with two brutal facts. First, the spectrographs had already shown the light was times, not times, a reflection of the Sunday. The solar barcode was missing. Second, the polarimeters had confirmed the light was unpolarized. Light reflecting off a cloud of dust, especially crystalline dust, would be highly times polarized. It would be a textbook example of scattered light. The hypothesis was dead on arrival, another beautiful theory slain by an ugly set of facts. The frustration within the community was becoming palpable. In online forums, in academic preprint servers, and in hushed video calls between institutions, the debate raged. Every new data set seemed to close a door without opening a new one. Each observation only deepened the paradox. One desperate theory posited a phenomenon known as triboluminescence light, generated by the fracturing of materials. Could the interior of 3I Atlas be under immense stress, constantly cracking and grinding, causing minerals within it to emit flashes of light? Some crystals, like quartz, emit faint glows when crushed. Perhaps this object was a giant self-grinding space rock. While intriguing, the idea fell apart under the scrutiny of energy requirements. To generate the observed steady and incredibly bright output of 3I Atlas would require the object to be consuming itself at an astronomical rate. It would have to be pulverizing mountains of material every second, a process that would generate enormous quantities of dust and debris. We saw none. Telescopes trained on its wake found only empty space. Furthermore, triboluminescence is typically a sporadic, crackling phenomenon, not the serene, constant, and spectrally pure glow we were witnessing. It was the light of a blowtorch, not a firecracker. The more we learned, the less we knew. The object was too bright to be passive, yet too clean to be active. It was too stable to be outgassing, yet too luminous to be solid. It obeyed the laws of gravity with perfect Newtonian grace, yet it violated the laws of optics with cheerful abandon. A final, somber hypothesis was considered. Could we have witnessed a singular cataclysmic event? Perhaps 3I Atlas was a dark body, an inert chunk of rock or ice that had been invisible for eons, only to be struck by a smaller high-velocity impactor just before we spotted it. The impact could have vaporized a vast amount of material, creating a temporary expanding cloud of hot plasma that would glow brightly. This would explain the sudden appearance. For a short time, this seemed plausible. It accounted for the brightness and even the lack of a typical cometary signature, as the physics of a hypervelocity impact are far more violent and exotic than gentle sublimation. But the theory had a fatal flaw time. An impact cloud is an explosion. It expands, cools, and fades, and it does so rapidly, usually over a matter of hours or days. Yet 3I Atlas did not fade. Week after week, its light remained impossibly constant. Its brightness curve was a flat line, a testament to a steady-state energy output that an explosion simply cannot explain. An impact event is a shout. This was a ceaseless hum. It was a sustained broadcast from the void. And with the collapse of this last desperate idea, a profound and unsettling silence fell over the astronomical world. We had exhausted the conventional playbook. Comets, asteroids, dust clouds, geological activity, impact events. Every natural phenomenon we had ever observed or conceived of had been proposed, modelled, and decisively ruled out by the cold, hard data. We were left staring into the abyss, holding a set of observations that could not be explained by the physics of our solar system. The object was not just an anomaly anymore. It was a refutation. It was a quiet, luminous messenger from an unknown context, patiently waiting for us to ask the right questions, forcing us to confront the terrifying possibility that our catalogue of the cosmos was missing a chapter. And as the object continued its serene journey, its strange light washing over our bewildered planet, we had to face the chilling reality that the next hypothesis would have to come from somewhere far beyond the realm of the familiar. And so every path we took, every logical road our science had paved over, centuries led us to a place of profound and unsettling darkness. The nitrogen iceberg hypothesis, elegant in its simplicity, had shattered against the hard wall of the data. The hydrogen sail concept, a beautiful piece of theoretical physics, offered no explanation for the object's bizarre thermal stability. Every natural explanation, from a simple comet wrapped in an exotic shell to a fragment of a destroyed dwarf planet, had been meticulously modelled, tested, and ultimately discarded. They failed not because our models were wrong, but because the object itself refused to obey the rules of our universe. We were left with a ghost in the machine of the cosmos, a visitor that defied every category we tried to place it in. The silence in the world's great observatories was not one of peace, but of intellectual exhaustion, the quiet that follows the collapse of every known assumption. We had exhausted the possible. What happens when you exhaust the possible? For generations, the answer has been to re-examine your data, to refine your models, to search for the subtle error you must have missed. But the data from 3I, Atlas, was ruthlessly, impeccably consistent across dozens of instruments on and off the planet. The models were sound. The inescapable conclusion whispered at first in late-night video calls between exhausted astrophysicists was a scientific heresy of the highest order. It was an idea so profound, so paradigm-shattering, that to even voice it felt like a betrayal of objective reason. The problem, this heretical thought suggested, was not in our understanding of what the object times was times, but in our most basic assumption of what we were seeing. We had been working from a single foundational premise that we were observing sunlight reflecting off a surface. It is the basis for nearly all observational astronomy of non-luminous bodies. But what if for 3I, Atlas, that premise was fundamentally cataclysmically wrong? What if the light we were seeing wasn't a reflection at all? This question, once spoken, hung in the air with the weight of a new physics. It reframed the entire mystery. Instead of a passive, inert object being illuminated by our star, this idea proposed an active, dynamic source. An object that was not merely passing through our system, but was performing. To entertain this, scientists had to go back to the very first photon captured from this enigma, to dissect the light itself, not as a simple messenger, but as a potential artifact. And when they did, 3 colossal anomalies previously treated as separate, frustrating puzzles began to snap together into a terrifyingly coherent picture. The first and most profound of these was the object's spectrum, the very rainbow of its light. When sunlight, a product of thermonuclear fusion, bounces off a surface like an asteroid or a comet, it retains the chemical signature of the sunday. Its light, when broken apart by a prism, shows specific dark lines, Fraunhofer lines, where elements in the sun's atmosphere have absorbed certain frequencies. It's a celestial fingerprint. The light reflected by any object in our solar system carries this fingerprint smeared and altered slightly by the material it reflects from. But the spectrum of 3I, Atlas, was impossibly clean. It possessed none of the telltale absorption lines of our sunday. It was as if the light had never been near it. This alone was baffling enough to cause serious consternation, leading to early rejected theories that it was somehow masking the solar signature. The truth, however, was far stranger. The light wasn't just missing the sun's fingerprint. It carried a spectral signature entirely of its own. It was not a thermal spectrum, the continuous, gently rolling curve of energy you get from a heated or illuminated object. Instead, its spectrum was dominated by a series of incredibly sharp, narrow emission spikes, thin as a razor's edge, at frequencies that corresponded to no known natural atomic transition, no predictable quantum leap of an electron in any element we have ever discovered. It was a forest of luminous needles standing against a backdrop of near-total darkness. You see, nature is messy. The light from a star, a nebula, or a reflected glint is a broad, chaotic chorus of countless atomic interactions. It is a symphony played by an orchestra of trillions with instruments slightly out of tune, blending together into a continuous roar of energy. The light from 3I, Atlas, was not a symphony. It was a single pure note held with impossible precision, then another and another, all perfectly defined. This was not the signature of heat or reflection. This was the signature of a process, a mechanism of immense sophistication. It was the kind of ultra-pure monochromatic light that here on Earth we can only produce in our most advanced laboratories using high-powered, carefully tuned lasers. It was a non-thermal spectrum, meaning the light was not being generated by heat. It was being generated by some other, far more controlled energy conversion process. The object wasn't glowing because it was hot. It was glowing because something inside it was turning energy directly into these specific surgical frequencies of light with near-perfect efficiency. It wasn't reflecting light, it was building it photon by photon. This discovery alone was enough to rewrite every textbook, but it was only the first piece of the mosaic. The second anomaly came from the Athens Polarity Group, a team specializing in one of the most subtle properties of light, its polarization. Think of a light wave as a vibrating string. In normal unpolarized light from the sun or a light bulb, these vibrations are random, happening in all directions perpendicular to the direction of travel. It's a chaotic jumble. When this light bounces off a surface, some of that chaos is organized. The reflected waves tend to become partially aligned or polarized in a specific direction, like smoothing down the fibers of a tangled rope. The amount and angle of this polarization can tell you incredible things about the texture, composition, and even the physical state of the surface it reflected from. For weeks, the Athens team had been struggling with the polarization data from 3I Atlas because it made no physical sense. The light wasn't partially polarized as you would expect from any natural reflection. It was almost 100% polarized. Every single photon arriving from the object was vibrating in perfect, unwavering alignment. Imagine a billion people leaving a stadium scrambling in every direction. That's unpolarized light. Now imagine them leaving in a perfectly formed single-file line, each person facing the exact same direction. That is what we were seeing from 3I Atlas. This level of coherence is simply not something nature produces on a macroscopic scale. Reflection from dust, ice, or rock, no matter how smooth, always induces a degree of randomness. It scatters. To achieve near-perfect polarization requires a mechanism that generates the light in that state from the very beginning. It implied a source, a luminous surface or emitter, with a crystalline-like internal structure of unimaginable order. The light wasn't being filtered or reflected into alignment. It was being born into it. It was structured light. When the Athens data was combined with the spectral data from the Mauna Kea spectrograph, the implications became breathtaking. We were witnessing an object that was generating its own purely monochromatic light, and then emitting it in a perfectly organized, polarized wave. This was not a cosmic accident. These were two independent, highly improbable characteristics, pointing to the exact same conclusion, a process of deliberate and controlled light generation. The object wasn't just a lamp, it was a quantum-engineered projection system of staggering capability. But there was still a third anomaly, perhaps the most unsettling of all, that sealed the argument and pushed the entire scientific community across the threshold of this new terrifying reality. It was the way the object's brightness changed over time. For any natural object, brightness variations or its light curve are predictable. An irregularly shaped asteroid tumbles through space, and its brightness flickers in a repeating periodic rhythm as different-sized faces are presented to our telescopes. A comet's brightness might change more erratically as jets of gas burst from its surface, but these outbursts are still fundamentally chaotic, following the laws of thermodynamics and sublimation. The light curve of 3I Atlas followed neither of these patterns. Its brightness didn't just vary, it modulated. It pulsed in a sequence of such intricate and profound complexity that it defied all analysis based on rotation or outgassing. The fluctuations were not random, nor were they simply periodic. They contained layers upon layers of nested patterns, some repeating over hours, others over days, but never in a way that suggested a simple physical tumble. For months, supercomputers hunted for a rotational model that could explain this complex flicker. They tried modeling the object as a bizarre collection of attached lobes, a spinning shard with complex surface features, even a binary system of two objects orbiting each other. Every model failed. The pattern was too deep, too structured. It looked less like the glinting of a tumbling rock and more like a broadcast. The pulses would sometimes be sharp and quick, like a cosmic strobe light. At other times, the brightness would swell and fade in a slow, hypnotic sine wave of perfect mathematical purity. There were even periods of absolute, unwavering intensity where for hours on end its luminosity did not change by even a single part per million, a stability unheard of for any celestial body, which is always subject to minor surface changes and imperfections. It was as if the object had different modes of operation. When you put the three pieces together, the intellectual straitjacket of a natural explanation simply evaporates. The non-thermal spectrum tells you the light is being manufactured, not reflected. The perfect polarization tells you the manufacturing process is incredibly ordered and precise. And the complex non-rotational light curve tells you that the output of this process is being deliberately controlled. There is no other conclusion that fits the evidence. It is a conclusion that sits uncomfortably at the intersection of physics and philosophy, a place where science rarely dares to tread. 3I Atlas is an active technological object. It is a machine. a machine that is, for reasons we cannot possibly fathom, generating a beam of structured light and projecting it out into the cosmos. This realization changes everything. The questions we had been asking were suddenly rendered obsolete. We had been consumed with figuring out its origin, its composition, its trajectory. Were these even the right questions anymore? If it is a machine, then its material makeup is secondary to its function. Its trajectory is not a passive orbit dictated by gravity, but a deliberate course. And its origin? That question now carried an impossibly heavy weight. We were no longer studying a piece of interstellar debris. We were observing a manufactured artifact of unknown purpose and unknown origin, an artifact that had fallen silent for decades as it coasted through the interstellar void, only to power up to begin this strange luminous performance as it entered the warm gravitational embrace of our own solar system. The focus of our science had to shift from geology and chemistry to engineering and information theory. The models of cometary nuclei and nitrogen icebergs were swept from the whiteboards, replaced by schematics of energy conversion systems and signal processing diagrams. How could such a machine generate this much energy so efficiently, so far from any star? The total energy output, while small in stellar terms, was colossal for an object of its size, rivaling the output of a nuclear reactor. Yet there was no detectable heat signature, no trail of exhaust, no waste products of any kind. This suggested an energy source that operates on principles we have not yet even conceived of, perhaps a direct mass-to-energy conversion that is nearly 100% efficient, or a way of harvesting zero-point energy from the vacuum of space itself, concepts that live on the fringes of our theoretical physics. And the light itself, if it is a projection, what is it projecting? The complex modulations, the intricate pulses, the unnervingly structured patterns, are they merely a byproduct of some internal process, the hum of a great engine, or is this the purpose? Could the fluctuations be a form of communication, a message encoded in the very fabric of the light? Is it a beacon, a celestial lighthouse sweeping its beam across the galaxy, and we have just been lucky, or perhaps unlucky, enough to have our star system drift into its path? The perfect polarization and monochromatic nature of the light would make it an ideal medium for transmitting information over vast interstellar distances, a signal that could retain its integrity over thousands of light years, slicing through the dust and gas of the galaxy with minimal degradation. Is 3i, Atlas, talking? And if so, is it talking to us? We have crossed a Rubicon. The comfortable, predictable cosmos of inert rocks and burning stars has been violated by an intruder that obeys a different set of rules, a set of rules that implies intent. The mystery of 3i, Atlas, is no longer a simple astronomical puzzle to be solved. It has become a direct and profound confrontation with the unknown. We are staring at a piece of technology so far beyond our own that we are like ants contemplating a supercomputer. We can see the lights blinking, but we have no possible framework to understand the calculation being performed. For the first time since we first looked to the heavens, we are faced with the chilling, exhilarating possibility that we are not just looking at the universe through this silent, luminous emissary might just be looking back. To suggest that this silent traveler is not a passive mirror, but an active projector, is to do more than just describe an anomaly. It is to ignite a fuse leading to the very foundations of our understanding, forcing a profound and uncomfortable choice. Because once you accept that the light originates from times 3i, Atlas, you find yourself standing at a stark fork in the cosmic road. Down one path lies a physics we have never imagined. Down the other, a creator we have only ever dreamed of. This single baffling observation created a schism that ran through the heart of astronomy, dividing colleagues, sparking furious debate in journals, and filling lecture halls with attention not felt for a century. The battle lines were drawn. On one side stood the guardians of scientific conservatism, brandishing the timeless principle that extraordinary claims demand nothing less than extraordinary evidence. They argued rightly that to leap to conclusions of artificiality was to abandon the rigorous methodical process that has built the entire edifice of modern science. Every alternative, no matter how exotic, must be exhausted first. On the other side were those who argued that the evidence before them times already extraordinary, that to ignore the most direct interpretation of the data simply because it was unsettling was a failure not of rigor but of nerve. The question hanging in the charged air was not just what is it, but a far more personal one. What are we willing to consider? Let us walk the first path, the one of caution, the one that seeks an answer within the grand impersonal tapestry of nature. If 3i, Atlas, is a natural object projecting its own light, then we have stumbled upon a completely new chapter in astrophysics. It would mean our census of the cosmos has been missing a fundamental category of object, one that operates on principles that currently lie outside our most advanced theories. Scientists scrambling to devise a natural explanation began to sketch out the theoretical possibilities, each more exotic than the last. Perhaps they offered the object as a unique form of pulsar, but one that emits energy not in the radio spectrum but in a tightly focused visible beam. This hypothetical optical pulsar would require a neutron star of impossible density and magnetic field geometry, a celestial unicorn for which we have absolutely no precedent. Others proposed a bizarre form of large-scale sustained piezoluminescence. The idea is that the immense tidal stresses and gravitational shearing forces experienced during its ejection from its home system and its long journey through interstellar space could have compressed its crystalline structure to the breaking point. This immense pressure could theoretically be released, not as heat or kinetic energy, but as a constant, brilliant stream of photons, a cosmic diamond crying out in light. Then came the even more speculative models, ideas born from the fringes of theoretical physics. Could it be an object composed of some strange, stable exotic matter, a quark nugget left over from the Big Bang? In this scenario, the object wouldn't be projecting light in the conventional sense, but its very substance would be, annihilating stray interstellar particles that touch its surface, converting their mass directly into radiant energy with terrifying efficiency. It would be a ghost haunting the cosmos, glowing with the souls of consumed atoms. Each of these theories, while straining credulity, shared a common virtue: they did not require a creator. They preserved the universe as a place of profound, but ultimately mindless physical laws. A discovery of this magnitude would still reshape our textbooks. It would be a Nobel Prize-winning revelation, proving that the universe is still filled with wonders far beyond our current comprehension. A place where even a simple rock under the right conditions can become a lantern in the void. It was a beautiful, compelling, and scientifically respectable position. It offered a sense of wonder without demanding a complete re-evaluation of our place in the cosmos, and for many this was a far more palatable mystery than the alternative. But the data remained stubborn. The light from 3i, Atlas, was too stable, its beam too coherent, its spectrum too clean. It did not flicker or pulse like a natural energy release. It did not have the spectral signature of annihilating matter. It looked for all the world like it was engineered, and so we are forced to turn and face the second path. The path that leads into a territory of both breathtaking excitement and existential dread. To entertain this possibility is to accept that this tiny point of light is not a geological freak, but a technological artifact. It is the product of a mind, of a will, of a purpose, and in that moment the question shifts from what is it to the one that truly matters: who built it and why. The implications are so vast, so world-altering, that to even speak them aloud feels like a transgression. It would mean the culmination of centuries of human searching. It would mean that out in the vast cold darkness someone else is holding a lamp. Suddenly the science of astrometry and spectroscopy becomes entangled with the deepest questions of philosophy, theology, and the very definition of humanity. If it is artificial, what is its function? The most immediate and compelling theory is that the light is a form of propulsion. We ourselves have dreamed of this, sketching out designs for light sails pushed by powerful lasers stationed in our own solar system. But 3i, Atlas, appears to be something far more advanced. It is not being pushed by a beam from its home star. It seems to have brought its engine times with times it. This suggests a photon rocket, an engine that generates its own incredibly powerful beam of light and uses the sheer pressure of those outbound photons, their conservation of momentum, to generate thrust. Imagine a celestial blowtorch of unimaginable power. Each photon, though massless, carries momentum. Eject trillions upon trillions of them per second in a single direction, and you create a gentle but relentless acceleration. It is the ultimate expression of Newton's third law. For every action, there is an equal and opposite reaction. The action is the beam of light, the reaction is the forward motion of the craft. Over millennia in the frictionless vacuum of space, this constant, subtle push can build to astonishing velocities, allowing for journeys between the stars. But to create such a drive is to wield a level of power that is to our civilization functionally indistinguishable from magic. Let's consider the energy required. To propel an object even the size of a small asteroid to a fraction of the speed of light using photon pressure, the energy output of the beam would need to be astronomical. We are not talking about the output of a power plant, or even all the power plants on Earth combined. The calculations suggested an energy source that would have to dwarf the total energy consumption of our entire species by many orders of magnitude. The power being continuously unleashed by this tiny object would be comparable to the output of a small star, yet it is somehow contained within a structure no more than a few kilometers across. Where could such energy possibly come from? The speculation leads us to technologies that exist only in our most ambitious science fiction. Perhaps the object is built around a harnessed singularity, a microscopic artificial black hole slowly bleeding off its mass as pure energy through Hawking radiation, a process we can describe mathematically but cannot hope to replicate. Or maybe it runs on a controlled matter-antimatter reaction, the most efficient and volatile fuel source in the universe, where the complete annihilation of matter creates a fountain of pure convertible energy. To build and control such a device would require a mastery of physics and engineering that is centuries, if not millennia, beyond our own. It would imply a civilization that can manipulate the fabric of space-time, that can create and contain states of matter we can only dream of. A civilization that falls firmly into the category of a Type 2 on the Kardashev scale. A species that has transcended the energy limitations of its home planet and can harness the full power output of its parent star. They would be to us as we are to the first hominids chipping away at flint. The light from 3i, Atlas in this context, is not just a strange glow in the sky. It is the exhaust plume of a godlike technology, a casual display of power so immense it challenges our very definition of what is possible. It is the cosmic equivalent of seeing a supercarrier sail past an island inhabited by a pre-contact tribe. We can see it, we can recognize it as a vessel, but we cannot possibly comprehend the industrial and scientific base required to construct it. But what if propulsion is merely a secondary benefit? What if the primary purpose of the light is not to push but to speak? Perhaps 3i, Atlas, is not a vehicle but a messenger, a beacon. For over half a century, our own search for extraterrestrial intelligence, SETI, has been defined by listening. We have pointed our radio telescopes at the heavens, straining to hear a faint artificial whisper amidst the cosmic static. We have been waiting for a call. We never considered that the message might not be a whisper, but a shout made of light. This object is not trying to hide. It is broadcasting its presence across interstellar distances with an unmistakable signal. If it is a message, it is the most robust and enduring form of communication imaginable. Radio waves disperse and get lost in noise. A physical probe can be destroyed, but a beam of coherent light, a celestial lighthouse sweeping through the dark, is a signal that can travel for eons, waiting to be seen by any emerging intelligence that has just learned to look up. If we accept this hypothesis, then we are confronted with an entirely new set of questions. Is the light itself the message, its frequency, polarization and intensity, modulated in a complex pattern that carries information, a language of photons we have not yet learned to read? Are we right now staring at an encyclopedia of a galactic civilization, a technical manual, a work of art, or a history of a species long dead, and we lack the Rosetta Stone to decipher it? The sheer, unwavering stability of the light could be the carrier wave for a message of incredible density. Or is the message simpler? Perhaps its very existence is the message. It could be a territorial marker, the equivalent of a no trespassing sign for a vast sphere of influence. It could be a welcome sign, a part of a galactic network of beacons designed to guide emerging civilizations like ours into a larger community. A single lighthouse in a network of thousands, forming a map of safe harbors across the galaxy. Or the purpose could be darker. It could be a warning. In a silent universe, a bright light could be a danger signal, a flare fired to alert others to some unseen cosmic predator, or a cataclysmic event from which its creators fled. The light might be saying, "Do not come this way," or perhaps learn from our mistakes. This single point of light becomes a vessel for all our hopes and all our fears. The idea that another intelligence would expend such colossal energy to send a message implies that they believe there is someone out there to receive it. It suggests that on some level they believe in us. They have cast their message in a bottle into the cosmic ocean, and it has finally washed ashore. The burden now is on us. Can we open the bottle? Can we understand what is written inside? And are we prepared for what it might say? The silence of the universe has been our defining companion throughout human history. The projection hypothesis for 3i, Atlas, suggests that the silence has been broken not by a sound, but by a light. Then there are the possibilities that defy our human-centric imagination, purposes so alien that we may never truly grasp them. The light might not be for propulsion or communication, but for something else entirely, a function related to goals and sciences we cannot yet conceive. Perhaps 3i, Atlas, is a cosmic survey tool, a wanderer that paints star systems with its beam. It illuminates planets, moons, and asteroids, and sophisticated sensors aboard the craft analyze the reflected, scattered, and absorbed light, building a three-dimensional map of a system's resources and inhabitants in a matter of days. In this scenario, we were not just an accidental discovery. We were scanned. We were catalogued. The beam it projects is an instrument of galactic cartography, and its visit to our system was not a passage but an inspection. Or maybe it's something even grander. Could it be a terraforming engine, an interstellar gardener that travels from one nascent solar system to the next, using its focused energy beam to gently nudge the orbits of planets to boil away the ice on frozen worlds, or to catalyze the chemical reactions needed to create a primordial atmosphere? A device that does not seek out life, but creates the conditions for it, an agent of panspermia on a scale we can barely fathom. The most humbling and perhaps most likely possibility is that its purpose is utterly incomprehensible to us. We are trying to understand a superintelligence's motivations through the lens of our own limited planetary concerns, travel, communication, survival. It is like an ant on a sidewalk trying to understand the purpose of a symphony orchestra. The ant can perceive the vibrations, the movement of air, but it cannot comprehend the music, the emotion, the culture that produced it. The light from 3i, Atlas, could be an instrument in some galactic scale experiment we are not part of. It could be a work of art, a purely aesthetic creation, whose only purpose is to be beautiful to its creators. It could be part of a religious ritual for a species that worships light. Or it could be a byproduct, a completely unintentional emission from a process so advanced that its exhaust is a star-bright beam of coherent light. The truth is, we are trying to solve a puzzle with only a single piece, and that piece could belong to any one of a million different pictures. Whichever path we choose, natural phenomenon or artificial construct, the two trails converge again at a single unavoidable mountain, the sheer terrifying scale of the energy involved. There is no escaping the physics. To generate this light 3i, Atlas is consuming and converting energy at a rate that beggars belief. If our sun's total output were represented by the light of a great bonfire, then the energy driving this tiny object would be a welding torch held an inch from your eye. The object is a pinpoint, yet it radiates with the power of a small nation's entire electrical grid, and does so continuously. This is not a burst, it is a constant, enduring state of being. The sheer existence of such a power source contained and controlled is a statement. It tells us that there are energy regimes available in this universe that we have not yet tapped, that the laws of physics permit technologies of breathtaking consequence. Whether this power source was forged in the heart of a bizarre star or in the manufactory of an elder race, its presence in our solar system is a profound lesson in humility. It demonstrates that our most powerful machines are but children's toys compared to what is possible. The light from 3i, Atlas, is a testament to the power that lies sleeping in the fabric of the cosmos, waiting for someone or something with the knowledge to awaken it. The debates in the halls of science raged on, fueled by tantalizing insufficient data. Models were built, papers were published, reputations were staked, but every argument, every elegant theory, every desperate plea for a natural explanation ultimately crashed against the same unyielding shore of mystery. The object itself was now receding, its faint but persistent glow growing ever fainter as it headed back out into the interstellar darkness. We had a brief, fleeting glimpse of something extraordinary, a visitor that posed the most fundamental question we could ever ask. It gave us no easy answers, only a stark choice between a new physics or a new reality. To solve this enigma, to quiet the debate, we need more than theories. We need more data. We need to look closer. But our visitor is already leaving, and the window of opportunity is closing fast. The need to understand what has just passed through our home has become more than a matter of scientific curiosity. It has become an existential imperative. And so the silence that followed the collapse of that final desperate model was not the quiet of resolution, but the deafening hush of a paradigm being shattered. Every conventional explanation, from a strangely outgassing comet to a tumbling shard of alien technology reflecting our own star's light, had been systematically, brutally dismantled by the unyielding data. The truth, once a ghost haunting the edges of our calculations, now stood fully formed in the center of the room. 3i, Atlas, was not a mirror, it was a lamp. In the cold, starless void between suns, this impossible traveller was generating its own inexplicable radiance, a silent broadcast with no discernible purpose and no identifiable source. For the first time in our history, we were staring at an interstellar object that was not just passing through but actively announcing its presence with a steady, unwavering photon stream. The immediate aftermath was a period of profound scientific dislocation. Laboratories that had been buzzing with the energetic debate of competing theories fell into a state of contemplative shock. It was a moment akin to the first time a mariner realizes the light on the horizon is not a star, but the beacon of an unknown shore. What do you do when the map you have spent centuries perfecting suddenly proves to be missing a continent? You don't discard the map, you are forced to accept its incompleteness, to acknowledge the vast, terrifying blank spaces you had never before conceived. A cognitive dissonance rippled through the global astronomical community, a schism between the evidence their instruments were screaming and the fundamental principles they had held as sacrosanct. The laws of physics had not been broken, but we had clearly catastrophically misunderstood their application. We had encountered a phenomenon for which we possessed no grammar, no vocabulary. But science does not remain stunned for long. That initial shock quickly sublimated into a fierce, galvanized resolve, igniting the most ambitious and frantic observational campaign in human history. The world's greatest astronomical instruments, our magnificent eyes on the universe, were pivoted like the guns of a great fleet turning to face a single, unbelievable foe. The James Webb Space Telescope, designed to peer back to the dawn of creation, ceased its cosmic archaeology. Its precious, overbooked observation time was commandeered, its golden mirror swiveling to stare deep into the soul of this local enigma. The mission was no longer to simply measure the light's brightness, but to dissect it, to perform a photonic autopsy with a precision previously unimaginable. Every proposal, every long-planned project to study distant galaxies or nascent stars was either postponed or cancelled. The debate was fierce but short. How could we justify studying the echo of the Big Bang when a potential Rosetta Stone of the living cosmos was gliding right through our own cosmic backyard? Webb's infrared sensors were tasked with a singular, desperate hunt: waste heat. If 3i Atlas was a machine, a powered object, then it had to obey the second law of thermodynamics. Their times must times be some thermal signature, some faint telltale glow of inefficiency betraying the engine at its core. Teams of engineers and physicists worked around the clock, pushing the telescope's sensors to their absolute theoretical limits, stacking hundreds of hours of exposure to search for a spectral fingerprint that was orders of magnitude fainter than anything the instrument was built to detect. They were hunting for the ghost of a furnace, the whisper of an exhaust plume in the absolute zero of interstellar space. Parallel efforts using ground-based arrays like ALMA focused on the opposite end of the spectrum, searching for faint radio emissions, the crackle of energy conversion, or the hum of magnetic fields that might accompany such an impossible light source. Every single frequency, every possible channel was monitored. The entire electromagnetic spectrum became a net cast wide in the hope of catching anything besides those baffling perfect photons. Simultaneously, a second, more audacious front opened not in the observatory domes, but on the whiteboards and supercomputers of theoretical physics. The challenge was laid bare: invent a new box for this phenomenon to fit in. If no known natural process could explain 3i Atlas, then we had to hypothesize unknown ones. Radical theories once relegated to the fringe were suddenly pulled into mainstream discourse. Could this be evidence of zero-point energy extraction, a technology harnessing the quantum foam of space-time itself? Such a process would be perfectly efficient, producing light with no discernible waste heat, a perfect match for the maddeningly clean data. Others posited it was a product of controlled matter-antimatter annihilation, moderated with a level of precision that bordered on the magical. The equations were dizzying, elegant, and utterly untestable. They were spectres of pure mathematics, offering tantalizing glimpses of a universe far more complex and filled with potential than our terrestrial experience had ever led us to believe. A schism formed between those seeking a natural but unknown explanation and those willing to cross the final intellectual frontier. This latter group began to model what an intentional engineered light source would look like. They called themselves xenolinguists of the photon, attempting to reverse engineer the technology from its output. Was the light a byproduct of an interstellar propulsion system, a kind of wake from a drive we couldn't comprehend? Or more chillingly, was the light the times, purpose, times itself? Was 3i Atlas a probe designed not to listen, but to announce, a lighthouse sweeping the dark, looking for other ships, or perhaps a lure? These were not questions that could be answered by spectroscopy alone. They were questions that bled out of physics and into the realms of engineering, biology, and ultimately philosophy. The silence from the object was profound, yet the light it projected had begun to speak in a language of pure possibility, and its message was reshaping the very structure of our scientific inquiry. As the months of intense observation bled into a year, a strange and unsettling consensus began to solidify. It wasn't an answer, but rather a final collective admission of defeat on one front and the opening of another. The hunt for waste heat had yielded nothing. The search for ancillary emissions had come back empty. The object was cryogenically cold, radiometrically silent, and gravitationally unremarkable. It was for all intents and purposes a ghost that shone with the light of a small star. The scientific community, with the somber gravity of a court delivering a verdict that will change the world, began to formally accept the unbelievable. The official papers published in journals that had for centuries been temples of conservative, rigorous thought were worded with exquisite care, yet their implications were earth-shattering. They concluded that 3i Atlas was, by all available evidence, a non-baryonic matter object engaged in a process of active, localized energy to photon conversion of unknown origin. Stripped of its academic jargon, the message was simple and terrifying. Something out there from another star system has mastered the art of creating light from nothing. This conclusion, this solidifying of the impossible into accepted fact, marked the true climax of the saga. It was the moment humanity as a collective was forced to lift its gaze from the data plots and confront the sheer soul-crushing magnitude of what it had found. The object was no longer just a scientific puzzle, it had become a philosophical anchor, pulling our entire conception of the cosmos down into deeper, more turbulent waters. For all our history, we have looked out at a passive universe, a universe of beautiful, mindless physics. Stars burned, planets spun, galaxies collided, all according to a set of elegant, predictable rules. It was a grand but lonely stage, a cosmic coliseum, where we were, as far as we knew, the only audience. But 3i, Atlas, changed the very nature of that stage. The universe was no longer merely a backdrop of inert matter and energy. It contained actors, or at least it contained the time's works times of actors. The existence of a technology capable of generating light so efficiently implied a level of scientific mastery that was not just centuries or millennia beyond our own, but potentially eons. It was the difference between a child rubbing two sticks together to create a spark and a civilization that could command the quantum vacuum. This single object in its silent, luminous passage drew a new, humbling line in the sand. On one side stood humanity with our fission reactors, our chemical rockets, our clumsy grasp of the fundamental forces. On the other side stood this, a civilization, a power, a force that could craft and propel a perfect self-illuminating artifact across the interstellar gulf. The Great Silence, the famous paradox Fermi posed about the lack of alien signals, was suddenly recontextualized. Perhaps the silence wasn't empty. Perhaps we had simply been listening for whispers in a universe where others were communicating with light. Perhaps they weren't shouting with radio waves, but simply existing brilliantly in ways we were too primitive to recognize. This realization rippled outwards from the scientific community, cascading into the public consciousness. It sparked a strange global fusion of awe and existential dread. We were no longer alone, but we were also demonstrably no longer the most advanced kids on the block, not by a long shot. The knowledge that someone or something out there possessed this level of capability forced a planetary-scale moment of introspection. What does it mean for our future, for our security, for our religions, for our very sense of self? 3i, Atlas, held up a mirror to our species, and for the first time we saw ourselves not as the pinnacle of creation but as provincials, living on a quiet cosmic shoreline, just now noticing the passage of a truly enormous transoceanic vessel far out at sea. The light from that vessel didn't threaten us not directly, but it fundamentally and irrevocably altered our understanding of the ocean. And just as this new reality began to settle in, just as we started to grapple with the long-term implications of a universe that contained technological magic, the teams at the Very Large Telescope in Chile, who had been monitoring the light's polarization with obsessive regularity, found something else. It was a pattern so subtle it had been dismissed for months as instrumental noise, a statistical ghost in the machine. But it was there, and it was repeating. The light from 3i, Atlas, while constant in its overall intensity, was exhibiting a faint, almost imperceptible cyclical modulation in its polarization angle. It was not random. The oscillation was complex, a nested series of pulses and pauses with a prime number relationship, a pattern that nature in its chaotic elegance simply does not produce. It wasn't a message in the way we understood one. There was no hello world, no neat binary code. It was something far more alien, far more profound. It was like discovering a single repeating musical note hidden within the sound of a featureless waterfall. The light was not just being projected, it was being structured. The lamp, it turned out, was not just a simple bulb. It was a projector, and we had just barely begun to notice the image taking form on the screen. The climax was not the discovery that the object was artificial, but the dawning horror and wonder that its artificiality might have a purpose directed not just outward, but perhaps somehow toward us. We were no longer just observing a strange object. We were standing on the precipice of receiving a broadcast we were not remotely equipped to understand, a message carried on a beam of impossible light, sent from a place we could not imagine for reasons we could not fathom. The mystery of what 3i, Atlas times, his times had been supplanted by a far more urgent and terrifying question. What in God's name is it trying to times? Say times. And so the light from 3i, Atlas, fades a single impossible point, receding back into the cold, silent depths from which it came. It leaves behind not a crater, not a chemical trace on some distant moon, but something far more profound and permanent. It leaves behind an echo in our minds, a fracture in our understanding of the cosmos, a question mark branded onto the very fabric of our reality. Our journey with this enigma began, as so many do in astronomy, with a faint, unassuming smudge on a digital sensor, one more transient visitor in the endless celestial parade. We assigned it a name, a trajectory, a category. We believed we knew the story that would unfold, an ancient wanderer of ice and rock briefly awakened by the sun's warmth, performing its predictable, beautiful, and ultimately natural cosmic ballet before disappearing forever. How wrong we were! How beautifully, terrifyingly, and exhilaratingly wrong. We have traced its path from that first moment of detection through the cascading series of revelations that dismantled our certainty piece by painstaking piece. We watched as the greatest minds on the planet aimed their most powerful instruments at it, expecting to solve a puzzle and finding themselves confronted with a paradox. We followed the data as it flowed from telescopes on remote mountaintops and from satellites orbiting high above the distortions of our atmosphere. Each new photon collected, each subtle shift in its spectrum measured, was supposed to bring clarity. Instead, it brought a deeper, more resonant mystery. The object was not merely reflecting sunlight. That simple foundational principle of observational astronomy, the very first lesson any student learns, was rendered obsolete. It was actively, impossibly projecting it, generating it, manipulating photons with a physics that remains stubbornly, maddeningly beyond our grasp. Think back on that journey. Remember the initial dismissal, the frantic search for a natural explanation for some exotic form of fluorescence or an undiscovered cometary process. Remember the proposals, each more elaborate than the last, of electrostatic dust, levitation of bizarre chemical reactions in a cloud of unknown composition of a unique crystalline structure, catching the solar wind in some unheard of way. We threw the entirety of our cosmic playbook at 3I, Atlas, and it swatted every theory away with an indifferent silence. It wasn't a comet, for it had no coma, no tail, no outgassing that could account for its brilliance. It wasn't an asteroid, for its light was not the passive, borrowed gleam of sunbathed rock. It moved with the grace of a purely gravitational object, yet it shone with the fire of a self-powered beacon. This single, silent traveller has done more to challenge our place in the universe than 1,000 academic papers or a century of quiet observation. It has forced us to hold a mirror up to our own assumptions and to admit that the reflection we see is that of a species still in its infancy. For generations we have looked out into the void and comforted ourselves with the idea that while vast and ancient, it was fundamentally comprehensible. The universe we believed played by a single set of rules we were slowly but surely uncovering. Gravity, electromagnetism, the strong and weak nuclear forces, these were the pillars of our cosmic cathedral, the unshakable truths upon which we built our models of everything from quarks to quasars. 3I Atlas did not simply knock over a pillar. It revealed that our cathedral, magnificent as it is, may be standing in the shadow of a far larger, far stranger architecture we never even knew existed. It shattered the very definition of a celestial body. We have categories for things: planets, stars, moons, asteroids, comets. These labels are our attempt to impose order on the chaos to make the universe knowable. But what box do you place this in? It is not nature as we understand it. It is not life as we can conceive of it. To call it an object feels like a profound understatement, like calling the Great Pyramid of Giza a pile of rocks. To call it a probe or a ship is to project our own familiar technologies onto something that may be operating on principles as far beyond our engineering as a starship is beyond a sharpened stick. 3I Atlas exists in a category of one. It is the ultimate anomaly, a ghost in the machine of the solar system, a piece of evidence that suggests the universe is not only stranger than we imagine, but stranger than we can times imagine. And this realization is not an ending. It is a violent, brilliant, and necessary beginning. The departure of 3I Atlas has irrevocably altered the future of our search for meaning beyond Earth. For decades, the search for extraterrestrial intelligence has been defined by listening. We have cupped our electronic ears to the heavens, waiting for a whisper, a stray radio signal, a deliberate mathematical broadcast from a distant civilization. It has been a patient, noble, and profoundly silent vigil. But what if we've been looking in the wrong place with the wrong senses? What if the hallmark of advanced intelligence isn't a radio wave, a form of communication tied to the specific evolutionary path of a species with hearing? What if the ultimate technosignature is the manipulation of physics itself? 3i Atlas suggests that the calling card of a truly advanced entity might not be a sound, but a physical impossibility, a defiance of nature, an object that moves without propulsion, a star that dims in a pattern that encodes information, a vessel that can generate its own light from the vacuum. The search is no longer just about listening for a message. It is now about looking for a miracle. We must now become cosmic detectives, scanning the skies not just for patterns that make sense, but for anomalies that make no sense at all. The next great discovery might not come from a radio telescope, but from a gravitational wave detector noticing a ripple with no source, or a spectrograph finding an element that cannot be forged in any known star. The game has changed. We are no longer searching for pen pals. We are searching for gods, for engineers of reality, for intelligences whose thoughts are written in the language of space-time and energy. This in turn ignites a revolution in the most fundamental of our sciences. For physicists, 3i Atlas is not just a curiosity, it is a gauntlet thrown down, a challenge to the very core of their discipline. The standard model of particle physics, our best description of the universe, has no room for an object that projects light without a discernible energy source, without waste heat, without violating the laws of thermodynamics. Its existence demands new ideas. It demands that we push beyond the comfortable confines of established theory and venture into the wild frontiers of speculation. Does 3i Atlas harness zero-point energy, the ghost-like quantum fluctuations that simmer in the fabric of empty space itself? Is it a vessel constructed from exotic matter, with properties that bend light and energy in ways we have only dreamed of in science fiction? Could it be a form of sentient information, a computational matrix that has learned to manipulate the physical world at a quantum level, essentially programming reality to suit its needs? These questions, once relegated to the fringes, are now being discussed in the halls of our most prestigious universities. It has given us permission to dream again, to ask the biggest, boldest questions, because we now have one undeniable piece of data that proves the universe is capable of producing things far beyond our current comprehension. It is the ultimate motivation, a tangible artifact that tells us the secrets still waiting to be uncovered are greater than all the knowledge we have accumulated in our entire history. Perhaps most importantly, 3i Atlas forces us to prepare. It was a fire alarm in the night. We were not ready. We detected it, we tracked it, but we were fundamentally helpless spectators. It flew through our home, through our celestial backyard, and all we could do was watch it go. We had no way to get a closer look, no mission ready to launch, no probe that could be diverted to chase it down and study it up close. It was the scientific opportunity of a millennium, and it slipped right through our fingers. We cannot let that happen again. The next one may not be so benign. The next one may not pass by in silence. The legacy of 3i Atlas must be a new era of planetary defense and cosmic exploration, two sides of the same coin. We need a new generation of survey telescopes capable of spotting these dim, fast-moving objects much farther out, giving us years of warning instead of months. We need to develop and pre-position rapid response interceptors, robotic probes on standby, ready to launch at a moment's notice to rendezvous with the next interstellar visitor. Such a mission would be the most ambitious undertaking in human history, a robotic emissary sent to greet a traveler from another star system. It is a technological challenge, a financial challenge, but above all, it is a challenge to our will, to our foresight, to our ability to act as a unified species in the face of a truly cosmic event. We must graduate from being passive observers to active explorers of our own solar system. We must be ready to meet the universe halfway. Ultimately, this single distant point of light has given us the most precious gift an enigma can offer, a renewed sense of wonder. It is easy in our daily lives to forget the scale of it all. We are so consumed by the horizon, we can see that we forget the infinite horizon that lies beyond. 3i. Atlas has reminded us all, scientist and citizen alike, that the map of the universe is not only incomplete, it may be fundamentally wrong. We thought we were sailing a familiar ocean, and we have just received definitive proof of entirely new continents of sea monsters, of lands where the laws of our world no longer apply. So, when you look up at the night sky, don't just see the familiar constellations, the steady glow of the planets, the comforting band of the Milky Way. See it now for what it truly is. A realm of infinite possibility, a place of profound mystery, a theatre for phenomena that can shatter our every preconception. The silence you perceive is not necessarily emptiness, it is simply the quiet between acts. We have witnessed one impossible thing. How many more are out there traversing the darkness between the stars, waiting for their moment to enter the light? What other travelers are on their way? What other messages are written in a language of impossible physics? The story of 3i, Atlas, is over. It has returned to the void, a fleeting whisper that we were lucky enough to overhear. But our story, the human story, has been forever changed by it. We are no longer just the inhabitants of a small blue planet, but the potential witnesses to a universe far more active, intelligent, and miraculous than we ever dared to believe. The darkness is not empty, it is full of secrets. And for the first time, we are truly finally beginning to learn how to see them. The journey is just beginning.